All right. So the densities, let me see if I can walk you through where I've gotten to so far. They have these two densities, and then this, if we just concentrate on the water for a second, does this make sense to everybody? That the force, it's just a force statement, right? And then, of course, we go with the densities instead of using mass. So the force, the buoyant force, is the density of water times volume of water that's displaced. Just to be clear, it's not the volume in the container, it's the displaced amount times gravity, and that's the density of the object, volume of the object times gravity. Cancel out gravities by using volume as area times height. We cancel out areas, and then I can get this ratio where I have the height in water over the total height is equal to the ratio of the densities. So what we see here is that I should also be able to say the height in benzene over the total height is equal to the density of benzene over to the density of the object. We can count. All right, so as Sophia has just pointed, well, so then, okay, is everybody cool? If we have these two things, we can solve things out because we know that the total height over the height in water is equal, or well, actually we can solve both of them for something instead of equal to each other that we don't know. Namely, we could probably solve both of them for the density of the object. So if we say, oh, do we know the density of the object? No, we don't, right? So the density of the object, well, the density of benzene times the over H. And once again, please check my math. Density of the object should equal the density of water times the height in water over H. Yes, or take the whatever T is. So then that means omega B HB over H is equal to omega W HW over H. Oh, interesting. So then from here, we can say that HB over H is equal to rho water over rho benzene times HW over H. Didn't they ask for the height above? The ratio of the height? So yeah, what I meant by writing was that if we know the fraction above or below, we can find the other thing, right? This down here is going to give us the fraction below. So what fraction below is sunk or whatever? What's the fraction of the object below the surface of benzene? Yeah, this is going to be 2/3 times 0.9, right? So it's 0.666 whatever, 0.66 times 0.9. So if you take 10% off, it's just like 0.6, right? So we get like 0.6 is below. So that means what must be floating above? Must be above. Save this. All right, so what we've done, if you've returned and joined us on our new adventure here, we were right up through here. What I did was I instead canceled out these H's and just said HB should equal to this. That gives us a 0.74 height. And of course, the answer in the book was the other way around. They gave the height under the water instead of the height above. But answering the question, that is above, which makes sense with our logic and works with the book's answer.